This is Oskopo Pajiman, a student of University of Cape Coast, Geography and Regional Planning. We are still on the research design, and today we are going to look at purely experimental design. That's the true experimental design. When we are talking about experimental design, then we are looking at the pure scientific research design that they use to test theories, they use to test issues and come out with a whole lot of findings about science. So when you look at this, we have a car that one is under control and one is the experimental group. So we are going to delve into true experimental research design. When you talk about experimental research design, then say that it is used when a researcher intends to test the effects of an intervention by manipulating the condition experienced by participants, while non-experimental research design is used when researchers intend to describe variables without manipulating the condition experienced by participants. What we are trying to mean is that when you talk about experimental research design, the researcher is interested in identifying the effect of one variable on the other by manipulating a certain group of variables so that the effects of said group can be measured on the other group. However, when you look at the non-experimental design, it's not so. Here we are interested in knowing the causal and effect relationship, but we don't want to manipulate any variable and control any variable, but we just leave them freely to interact for us to be able to measure such effects and causal relationship. Experimental research design is also referred to as intervention research because when the researchers manipulate the condition, they are intervening in participants' lives in some way. They are not just manipulating it for just manipulating sake, but they are just doing it. The researcher deliberately manipulates one or more independent variables. It is also called experimental variable or treatment condition. As I said, there might be two or more groups, but in this design, we are interested in manipulating one particular group for us to know the effect that it will be on the other groups. Here, we may do so by randomly assigning the individual or object to the experimental condition. So here we have the experimental or the control group and control groups on other environmental and exogenous variables. Looking at the balance scale that we have, what it was practiced in the olden days is that they will put a metallic that they know the value of such metallic in one of the balance, let's say the left one, and at the right one they will pack another metallic into that balance, or they will put another coins or anything in a value form, and they will measure the effects of that weight on the other balance. And as you increase the weight of the other balance, then it will move par with the value that they want. So they use that one to manipulate, let's say, the left one, and they see the effect that the left one will have on the right one. The same thing is what we are looking at. For instance, if you want to conduct a study, a drug, effect of a drug on, let's say, rabbits, how they produce. So what you do is that you have a two or more groups. One will be control group. That is where you are going to manipulate them. So these are the group that you are going to inject them with a drug. Then the other group, that one you will not inject them. They will also be at their different place. Then you rear them for, let's say, 3 months and see the one that will be fruitful, the one that will be on heat, and the one that it can go on heat and maybe to be pregnant and it will produce or reproduce of its kind. So what we are trying to mean is that in true experimental research design, there is a control or the experimental group and the other group, but we have to manipulate one group to know the effect that will come out. We also measure the effects of the independent variable on one or more dependent variables. Then after that, we are looking at some term that is associated with true experimental design. We have the pretest. When you talk about pretest, what we are trying to mean is that it provides a measure on some attributes or characteristics that you assess for participants in an experiment before they receive a treatment. For instance, looking at the rabbit that we want to know, those that will give birth to maybe more than 4 or 5 offspring or kids. What you are trying to hear is that before you inject the rabbit with that drug or that particular intervention, you need to measure the health, everything about the rabbit. Set in the case that after you have administered the drug or the intervention on that animal, then you also measure to know the differences. So that is what you mean by pre-test. So before the test, you need to measure them and know their condition and everything before the treatment comes. Then we also look at the post-test. When you talk about the post-test, we are looking at measuring the attributes or the characteristics of the participant or the object in the experiment after the treatment. So after intervening the animals with the drug or what have you, you need to also measure to know the response in order for you to know the differences that has occurred between before and after the intervention. In our example, this will be assessing student attitude towards smoking at the end of the semester after the experimental treatment. A pre-test and post-test comparison of attitude towards smoking would provide a clearer reading on actual smoking behavior than using the post-test measure alone. What we are trying to mean is that if you want to measure the attitude of students towards smoking at the end of the semester, you need to also measure their attitude before your intervention, and after the intervention you also measure so that you'll be able to compare before and after their attitude to know whether there has been a rare change in their smoking behavior. Another term is called matching. This is the process of identifying one or more personal characteristics that influence the outcome and assigning individuals with that characteristics equally to the experimental or control group. This is one way of controlling the confounding or extraneous variables. A blocking variable. There is a variable that the researcher controls before the experiment starts by dividing or blocking the participant into subgroups and analyzing the impact of each group on the outcome. Here, what we are saying is that before even the experiment starts, you need to group your participant into subgroup or any categorical group, and you be able to analyze the impact of such subgroups on the outcome of the study. We are looking at the advantages of the true experimental research design. So that experimental research design is most appropriate way for drawing causal conclusion. With this one, we'll be able to strongly affirm and conclude that a variable A affects variable B or cause variable B to do so regarding the intervention or treatment, and establishing whether or not one or more factors causes a change in an outcome. So here we'll be able to predict or be able to confirm and conclude that variable X or the drug is the cause of the fruitful or maybe the increase in the offspring or something like that. This is largely due to the emphasis in controlling extraneous variables. If other variables are controlled, the researcher can say with confidence that manipulation independent variables cause a change in the dependent variable. Here what we are saying is that as compared to the non-experimental design, such as the descriptive, correlational, and other things, that they don't have the ability to control or to manipulate the independent variables. Here we have the ability to control the independent variables and even to control other extraneous variables and confounding variables by through blocking and matching, so that at the end of the day you'll be able to confirm and boldly conclude that the independent variables has the causal relationship with the dependent variable. It is a basic, straightforward, and efficient type of research that can be applied across a variety of disciplines. Experimental research designs are repeatable and therefore results can be checked and verified. We are looking at the advantage. We are continuing. Due to the controlled environment of the experimental research, better results are often achieved since they are confined in a nice place and controlled environment. The research or the experiment can yield a better result as compared to other research designs that are conducted in the natural setting of the variable or the individual. In the case of laboratory research, conditions not found in the natural setting can be created in an experimental setting that allows for greater control of extraneous variables. For instance, if you are to test how a drug may affect the growth of a maize, creating an artificial environment for the maize at the laboratory will help you to minimize other factors or other pesticides and other insects and other diseases that can affect a maize on the natural setting. Conditions that may take longer to occur in the natural setting may occur more quickly in an experimental setting. There are many variations of experimental research, and the researcher can tailor the experiment while still maintaining the validity of the design. It is also much easier for other researchers to replicate the experimental and validate the results, since it uses a systematical way of coming or driving the truth, and also confine the experiment in a nice place, and also being able to control the extraneous and confounding variables. And by manipulating the independent variables, you'll be able to replicate such design or such study. We are looking at the disadvantages of this design. Experimental research can create artificial situations, as I explained in the maize situation and the rabbit, that do not always represent real life situations. For instance, as I said, when you create artificial environment for maize at the lab, it will be able to cater for other extraneous variables and other diseases and pests that might have attacked the maize when it is in the rare or natural setting. This is largely due to the fact that all other variables are tightly controlled, which may not create a fully realistic situation. Because the situations are very controlled and do not often represent real life situations, the reaction of the test subjects may not be true indicators of their behavior in a non-experimental environment. As I said, for instance, the maize. A maize grown in the lab might be far different from that same species or that same maize grown in the natural setting, due to the fact that it has created artificial environment for it, and also other extraneous and other variables have been highly controlled at the lab. Human error also plays a key role in validity of the project, as discussed. What we are trying to say here is that because human beings involved in assigning this group and other things, it may also introduce error to the research design. It may not be really possible to control all the extraneous variables, the health, mood, and life experience of the test, subject to the influence that, for instance, if you are to study human beings and that thing, you can't control every variable or the extraneous variables. Some you can control, some you cannot control, and those that we cannot control can affect the outcome of the study. The research must adhere to ethical standards in order to be valid, And when you are dealing with animals and human beings, you need to pass through strictly ethical clearance before you be given the guidance to continue this work, due to the harm and other things that they want to protect the individual and the animal from. Experimental research design helps to ensure internal validity, but sometimes at the expense of the external validity. When this happens, the result may not be generalized to the larger population. Therefore, all things must be done in order to ensure the internal validity and also for the external validity, that the generalization of the findings to be established. If an experimental study is considered to be in its natural environment, such as hospital or community, it may not be possible to control the extraneous variable, as I said. When you are to study the attitude of students with regard to smoking, there are other activities like friends moving out and other things that needs to be controlled. And it's not possible to control all these variables. And this may affect the outcome of the study. Experimental research is a powerful tool for determining or verifying causation, but it typically cannot specify why the outcome occurred. So what we are saying here is that though it can tell you that there is a causal relationship between this and that, but it cannot explain the causal relationship to you as to why this affects that, why this and that goes together. True experiments are also difficult and expensive to set up. They can also be very impractical. For instance, to measure or to study the attitude of students towards smoking, it will be very expensive to sponsor them. They go out, you have to follow them, trace them, their outings and other things. You have to trace them, and it might also not be impractical. Here what you are saying is that you can't put human beings at the lab and other things can be possible. So not all situations and other things that can be studied with the true experimental design. This brings us to the end of this lesson. Subscribe to our channel to get more updates on our research methodology and on research designs, more to come. And also don't forget that we'll be coming your way with quantitative data analysis. Thank you. Bye-bye.